All right.
Run with it.
Welcome to episode 25 of Roid Rage. This is me. I am Chap. I'm the host this week, and we have Demyan on to talk about ground stations and what that actually means in terms of how we talk to our spacecraft and what they do. Demyan, as a reminder, is a senior mission ops engineer here, and he's going to kick it off for us. So, before we get into it,
what about your other two more important guests?
You said you're here for the lulls, so like that automatically disqualifies you. And Robin's already in a grumpy mood.
But is it his lulls or our lulls that he's here for?
It doesn't matter. He can amuse himself with his own.
I've missed a few episodes, so
you have. Do you have some pent up dad jokes for us? Okay, all right. Going to the John Bernthal communication over here. All right, let's get us back on track. Demyan, welcome back. First, give us sort of ground comms 101. What are they? What do they include? What's a pass? What is a ground station actually made up of?
Yeah. So I think your phone is already doing spacecraft ground comms. You just don't know it. So the GPS signals are coming from space, and you have an antenna that's picking up those signals, and you're receiving stuff from basically about 20,000 kilometers away.
Okay.
Well, if my phone can do it, why the hell is it so hard?
We're a little further than 20,000 kilometers for one, but it's a good place to start. That if you have dish antennas like dish TV, you do satellite comms.
These are like the worst references.
Yeah.
DirecTV doesn't even exist anymore.
That's actually a fair point. Okay, I don't think anybody
I
in
think
our audience
DirecTV does, but Dish doesn't.
Hey, anybody that's 50 plus listening, when you had DirecTV in the fucking early 90s,
you were doing satellite communications. It was super fancy way back then. But even if we were flying something near Earth, like you can actually look this up yourself. Go to like Amazon Ground or something, and you can give them a credit card and like schedule a ground station and do. You do have to prove.
Do I get a discount if I have Prime?
Probably. I haven't tried this. But the thing is, if you're near Earth, this is pretty well. There's a lot of people doing this, and so it's been solved. It's been worked on a lot. So there's a lot of complexity at the ground station. We'll kind of come back to the complexity. But if you're in sort of the normal world of near-Earth spacecraft, somebody has already solved that for you, and you can kind of buy that service. You can pay for it. You can make that happen. And so a lot of what we're going to talk about is really like how deep space is different, I think, from a...
Can I take a stab at this? Because I'm going to be honest, Demyan, you're really good at everything except for giving explanations of what ground stations are, because that was terrible.
Tell me.
A ground station is simply how we listen and talk to the spacecraft. Right? It's a big dish on the ground that allows us to transmit signals to the spacecraft and receive signals from the spacecraft. It's really that simple. I don't want to add any more complexity to it than that. Now, we can go into sizing and all this and how it's different than LEO in deep space. But at the root all, it's just a big dish on the ground. That's it.
Yep. The big dish with a radio and some other components.
Some amplifiers.
A few other things.
Oh, wait, you got to point the dish.
We'll get to that one shortly. But but fundamentally, if you see a big dish,
probably internet to transmit that stuff back to our actual operations.
This is more complicated than just a way to talk.
No. Matt is always right. I would not dare challenge that Matt is always right. He might be incomplete on this one.
Got it. That's a very helpful reframing right there. All right, you mentioned a couple of components. Let's go into some of the details. So you mentioned it's got a radio, got a power amplifier. What else? What else makes up a ground station?
Yeah, so it's one side of a radio link is the same as So yeah, you have an antenna. It has to transmit and receive, so it has to get signals in both directions. To split those signals, there's an amplifier on each of those, and those go into a radio. Most complicated ground stations have other components to convert frequencies up or down, to adjust things, to route RF signals. But ultimately, it gets to a radio. In our case, the radio is digital. And then at that point, you put the data on the internet. So we try and make it as simple as we can. And each of the pieces by themselves is actually not that crazy. I think it's when you start putting them together and then starting to do 5 or 6 of them and put them all over the world and have, Tiger Watch or amplifier explosion and all those other things, that it starts to get really fun.
Because the obvious way in which they differ is they differ by dish size, right? So you can go from a couple meters all the way up to, what was the largest one we worked with? 32 meters?
Yeah. So 100-foot antenna in India. It's a little bigger than the dish TV antennas that you have never seen in your lives before.
And works far less reliably.
Well, let's use, like Starlink for anybody that's born, this century. pretty small antennas that communicate with the
I
spacecraft.
think that would be
right?
this decade, actually, but
Whatever. Going up and down, pretty small antennas. You can
Mhm.
hold them in your hand. You can even
Yeah.
get the mini versions and put them in the back of your car, right? As we go through. These are, the dishes that we use are out of James Bond movies, right? They're massive and they are 100 feet across, require a whole bunch of infrastructure to move, have to be extremely accurate, and because of that, are extremely expensive to use at the same time.
Yeah, and like other than one of the dishes, we wouldn't even consider anything smaller than 30 feet across or 35 feet across. It's like at that point too small.
Got it. And I'm assuming like dish size is variant, but they're same all in other respects, right? Because that would make our life a lot easier.
That would be nice. So this is kind of the other, yeah, would be nice. The other part of the kind of the challenge of deep space. So kind of talk a little bit about comms. This is the, you know, if anybody doing satellite communication would have the same kind of components, the dish is bigger. There's also for deep space, we need a really sensitive amplifier, and not all stations have them. So the first thing that happens is there just aren't that many options. Like not that many people have, 60, 70 foot dish just chilling in the backyard. We know one guy, but there's
Thanks, Peter.
yeah, thanks. But not many people have that laying around. But it's not just the dish. There's like a lot of very sensitive equipment that goes into it. On the receive side, they cool those amplifiers to like 100 degrees below zero or something crazy like that, just to get better performance out of them. So very kind of expensive, exquisite infrastructure. There's not a lot of it out there. And what makes our lives hard is being commercial. The first thing you're going to ask is, well, doesn't NASA do this? And they do. They do this, and they do this very well. But being commercial, we can't realistically use NASA's Deep Space Network or the Near Earth Network or any other NASA network. So this makes our lives a little more challenging.
Got it. And maybe just to illustrate for like the audience, can you describe what a nominal operation should look like? So we separate from the rocket.
Yeah.
What happens then?
Yeah, so we've planned in advance, right, where we think we're going to be. And so you could basically calculate, assuming the Earth is round, that where you have to point the antenna, which antennas are in view, and how you point the antenna to get the spacecraft in view. So we know, for example, we separated it for Odin basically above Madagascar, roughly. So we knew we were in view from Australia. So we said, hey, ground site in Australia, at this time, we need your antenna. Right, so you kind of know where you're going to be. You plan in advance, and you have we call a pass. And the pass is each time you schedule a ground contact. So from this, from 8 a.m. to 3 p.m., I want to use your antenna because I'm in view. We call that one pass, right? So or one contact. So that's, and then you schedule a bunch of these based on where you think the spacecraft is going to be, which is the first problem.
Say more about that.
Yeah. So before we launch, we have to schedule, right? And that means we haven't actually gotten into space yet, and we have to schedule antennas already. If we don't schedule, somebody else might, which then we can't use the antenna. Can't say that.
keeping in mind that there's only a few assets to choose from.
Yeah. So,
Wait, so what determines scheduling priority then?
ooh,
How much money you pay?
Who
Let's
gets
be
there
honest
first?
about it, right? It is. It's how much money you pay is what gives you priority as you go through this. And on our last launch, there was 5 other spacecraft on our vehicle. And guess what? They're all over Madagascar at the same time, right? Because we're all on the same rocket. Nobody's going to thrust within the first 5 minutes. So we're
Yeah.
all actually competing for the same ground assets at the same time.
yeah. I would say even the people who claimed they did first come, first serve scheduling didn't.
Not true.
And everybody else didn't even make that claim. They just said, please submit your requests here. So I think Matt's right. I think it's a
Okay.
A little of who you know
yeah.
and how much you've lined the pockets.
Well, the nice thing is there was a NASA mission on that Lunar Trailblazer, so that was done on DSN.
Yeah.
So we didn't have contention with DSN, so that was one off, right, as we went through. And we did on Odin, tried to use a very small dish. It was a 5-meter dish in Arizona. Arizona, Australia, same place.
Can't transmit the continental United States, man.
Yeah, we can go into all the issues we had, but pretty much the U.S. hates deep spacecraft.
Okay.
Mhm.
By law.
By law. The Congress actually specifically hates deep space.
The other thing that's different to think about for our mission, which was always fun to talk about, is I spent a lot of time working on rockets in low Earth orbit. In low Earth orbit, your pass is on the order of 45 minutes because it takes you 90 minutes to orbit the planet. The spacecraft is orbiting faster than the rotation rate of the Earth. On our launch, we were going directly away from the planet. So actually, our passes are 12 hours long, which means if there isn't an asset in that window that you can get in, there isn't like, oh, wait 5 minutes and you'll be over something else. It's long passes that take a lot of time, that take a lot of dish space. And we had to configure every single one to be unique for our spacecraft. The way that our configuration was done was not the same configuration to talk to the Athena spacecraft or to talk to Epic's Chimera or to even try to talk to Lunar Trailblazer. Those are all different configurations that had to be loaded on and tested to each one of these ground stations before they transmitted up. So it's extreme, and that's per station. It's not like the one in Australia was the same company as the one in India, which was the same. These are all disparate networks run by different people with different issues and different problems.
Yeah. To highlight that, we use dishes in 10 dishes, 6 countries, owned by 5 different providers. So that's a lot of talking to people, emailing people, testing things, coordinating things.
It's going to be so much better next time.
Yeah.
I want to turn the page, man.
Oh, I do want to turn the page. But another thing that I think Matt brought up that is important here is that the configuration change. There's one of the things we ran into that was a surprise to me is that these dishes, the big ones, are typically, they're used to having, big government contracts, big government spacecraft. So for them to suddenly have to switch from, oh, you have 3 spacecraft in view, they all want your time, and you have to switch your configuration from one to the other. They have never operated that way, and it was a challenge.
I mean, keep in mind during Odin, we were commanding 100-foot diameter dishes by calling some random person with a cell phone. Like this isn't well thought of because this is really where new space meets old space, right? This was, again, we were the first people to try this commercially. So when you do that, you challenge the status quo. This is a government-owned entity that's used to flying missions like Voyager and Cassini and Juno and these big monolithic missions for a long time in deep space.
But I guess, so for the first pass, obviously we sort of, we were, I'm going to say, clustered with a number of other spacecraft. How long does a pass normally last? And do you expect that clustering to still be true on the second pass? And how far in advance is that second pass?
Yeah, I think we were about 8 hours for the first pass, and we were already in view of the second station by the end of that pass. So, so about 8 to 10 hours per pass, and we stayed clustered where we were in the same view as other spacecraft until they fire their engines. I mean, almost forever. I mean, it's like days that we were in the same beam as other spacecraft. And then Intuitive Machines left because they successfully fired their engines, so they left the beam. We don't know if the others left the beam. We didn't see their signals.
They're still that mission's still active. I think they're
No, Lunar Trailblazer was officially shut down.
Oh, was it shut down?
Yeah, it was shut down
I thought they
3 days
were
ago.
still saying they were going to listen in a couple months.
No, that's a huge disappointment. Epic's Chimera also failed and did
Yeah.
not fire its thruster. I mean, it's a sad truth of reality of what we're taking on is every single mission on that spacecraft, on that rocket failed.
Yeah, that's a bummer.
None of them were successful. Certain ones got farther than others. I mean, Athena did land on the moon. It just landed sideways. But yeah, Epic's Chimera and Lunar Trailblazer all did not fire their thrusters.
And I think I know the answer to this, but just ask this outright. We didn't get early warning on, hey, we're not going to be able to prioritize you on your first pass. Like, did you find that out as we were going through that, or was that sort of like?
I feel like it was like a week out.
Yeah, it was. I think it was less than 2 weeks. Maybe 10, 12 days. And
Okay.
we learned that we were supposed to have 2 dishes covering our separation.
Yep.
Right.
Because that's kind of an important time. So you want to back up.
Yeah.
Mm-hmm. So we actually ended up using our backup dish because we couldn't get time on the primary for a few hours. So we only got time on the primary actually after we already were in view of the next station. So we did overlap, but yeah, it was hours later that we actually got access to the dish we wanted. And that's definitely a lesson learned. More dishes earlier planning. Part of the problem is you schedule early, and then typically there's a penalty for changing your schedule.
Okay.
So we haven't even launched. We don't control the launch. We're a ride share, which you've heard a lot about in other things. So we don't even know how likely we are to launch. And
Yeah,
we have
we
to make
just
a
we
decision.
basically have to be prepared for a lot of different contingencies.
Yeah.
Yeah.
And we've talked about that previously on mission planning with which asteroids. Part of mission planning is which ground stations and what backup ground stations and yeah.
Demyan, what were you expecting to go wrong prior to this? And did any of your expectations actually not come to realization?
Well, so a lot of things I expected to go wrong never had the opportunity to go wrong.
Got it.
So
I mean,
Wow.
a lot of our talks at the beginning were actually about impacting the moon.
yeah,
There was a real concern when we were put out in TLI that we would impact the moon if we were not able to command the spacecraft within the first couple days.
And to be clear, by impact to moon, you mean crash into that thing.
I mean, hit that thing.
Yeah.
I mean
Okay.
land, not very gently.
Yeah.
on the moon.
Land at about 20,000
Land
kilometers an
in a
hour.
somewhat violent manner.
yes.
Okay, that's very
lose
very-
the competition with gravity.
Yeah.
Yeah, that's true. So it was a very real risk, a known risk before launch. We'd actually calculated the chance of that. So we knew that. We had other known issues with just the configuration, the testing. So there were a lot of things that we knew weren't going to work as we intended, but they were already known. So those are like, I guess you'd call it like expected state. It
Yep.
wasn't the way I wanted it to be, but it was expected
Yep.
because we already knew about those. And so in terms of so I guess your question was which things didn't happen or did happen?
Which things were you preparing for that did not
Oh,
happen? So,
oh.
like, obviously, we did not crash into the moon that we know of.
Yeah. I think we were preparing for a lot of.
To be clear, we definitely did not crash in the moon.
Okay.
Yeah. We do.
We definitely know that.
I don't know. We were talking about comments that said space isn't real prior to this, so I'm just trying to establish facts here.
Yeah.
If the
Well, I'm
moon isn't real, you
establishing the
can't crash
fact.
into it.
We know that we did not.
No, we were able to track the vehicle.
Yeah.
Yeah. We have a signal after.
Little sensitive about that.
Yeah.
It's sort of an important fact.
Yep.
Some people would care, a lot.
No conspiracy theories on this.
But we had some pretty. Hey, look, this was pretty comical almost when you look back on. I mean, to the scheduling point, one of the things we realized early on is we weren't going to get scheduling over a very specific point over the Atlantic Ocean, and so actually a week before we brought on a dish in the Azores, and by bringing it on, we had a guy named Chris who started. I think
weeks before?
I don't even think it was 2
10
weeks. I
days?
think
No, it was that week.
It was that week he started. We're like, hey, Chris, since you're new and you got to be brought up to speed, would you mind getting on a plane and going to Portugal? And he's like, no problem. And then we informed him we actually met the little island owned by Portugal in the middle of the Atlantic called Santa Maria. And so he literally flew to Santa Maria. I think it took him almost a day and a half to get there.
Yeah, that's like a total of like a 3-day voyage.
Yeah, and
Because
that
you
was
have to actually fly to Lisbon to then fly back to Santa Maria.
yeah. So
Keeping in mind, we actually sent Bernie to Colorado to buy a baseband unit
we had to go get the unit.
for Chris to then meet her in LA.
Yeah, at
which
the
he did
airport.
At the airport
They
to
didn't-
then
yeah.
fly.
to
So,
then
like,
fly it out there. So he flies it out there.
because it wasn't Chris that
installs
was
it.
important in that. It's actually the baseband
Yeah,
unit.
actually, yeah.
We hooked that all up. We get that ready. I remember it being pretty treacherous rainstorms because we got some great images as we went through. And then what was it? The day before or 2 days before?
The day before, like within less than 24 hours before launch.
Within 24 hours before launch, the power amplifier blew up on the dish. And those dishes all are supposed to have secondary power amplifiers they keep as backups. Well, it was missing, to say the least. So then we went into contingency mode of we actually found a backup in Italy.
Yeah.
And we were trying to get a private carrier to fly it to the island from Italy so we could bring the dish back up so we could use it. And it ended up not working. But that's the level you had to go to. And to be clear, that story is repeated for almost every single one of these dishes in a different way, shape, or form of issues we had and problems we had to overcome just to be able to get this thing to listen, let alone talk to it.
Okay.
Yeah.
So it feels like the summary so far is we learned a lot of hard lessons the hard way.
Yeah, I want to look into the future.
Yeah.
Why? I don't want to ruminate about how hard it was. I want to talk about how much better it's going to be.
Yeah. So Demyan, like how obviously there's a bunch of stuff that's outside of our control. So we try to sort of tame that chaos as much as possible. Like what goes into your I'm going to use this term loosely, tooling stack to sort of tame that chaos?
Yeah, I think one of the things to remember about Odin is just time frame. And that time frame wasn't just for the spacecraft, it was for everything.
Yep.
Right? Remember when we took the spacecraft in-house, it meant we took the software, the ops software, the entire ground software, the scheduling, everything went in house, right? Because
Yep.
normally that would go through the bus vendor.
Yeah, we were, just to be clear, we were a hosted payload on our bus vendor. It wasn't like we actually bought the spacecraft. Even from a license perspective, we were a hosted payload.
Yeah, we didn't even have our RF license. Yeah, when we went, yeah.
So when we decided to bring it in-house, it was like, we're not bringing just the satellite in-house. We're bringing the licensing, the ground stations, the ops, all of that shit.
Mm-hmm. Yeah, and it was like an all-in-one decision. You got to. So that said, a lot of the things, partly as a consequence of that schedule, partly as a consequence this is what people just do in the old industry. There's a lot of things that are manual. Like I was scheduling via like pulling data from our software mission design tools into spreadsheets, then sending emails, sometimes WhatsApp messages, to schedule.
Sometimes phone calls.
Sometimes phone calls to schedule literally tens of thousands of dollars of ground contacts.
Yep.
Like, with just like, I would love to say that system was great, so let's make it better.
Yep.
And so we're basically building out a set of in databases in-house to say that we have a single source of truth for what are the parameters we're designing to. So
Yep.
like my mission design software that says I want the spacecraft to be here can basically cross communicate with the thing that says where's the antenna pointing.
Yep.
Oh, it's pointed where I expect it to point. It has the power I expect it to have.
Yep.
So a lot of that stuff that we just didn't have the time to build for Odin. We knew we wanted it. This stuff isn't a surprise. This is just development timeline,
Yep.
right? This is all stuff we knew we wanted. Now we have the time to build it. So let's build it. The scheduling, right? We have a single source internally for this is what we've scheduled. This is who's gotten back to us, who hasn't gotten back to us.
Yep.
So building all that out in advance lets us be a lot more organized, but also we can test all those pieces and test how they interact
Yep.
in advance. And I think that's the big part about controlling as much of the chaos as we can. There will be more chaos that is basically inevitable, but we can be a lot better prepared, both from the things we just didn't have time to implement and the things we learned.
Yep. And what is start to walk us through like actual testing here, right? We like, does that mean you're getting time on the prospective dishes that we're going to use for Vestri? Like, how are you thinking about this dish selection differently? Like, what does a test actually look like here?
Yeah. So I have two questions on the dish selection versus testing. The test, there's you could say we do a lot of testing here we have so we mentioned baseband unit, but that's the ground radio.
Yep.
Effectively. We have one here. We test in advance that the ground radio and the spacecraft radio talk to each other. We understand how to configure them, but then we need to go on site or to an RF lab and say, okay, like what we assumed, what we saw at home is what we see at this dish, because there's a lot more parts in the way. There's antennas, there's amplifiers, there's switches, and all that kind of stuff. And we want to make sure that all those things still talk to each other. And one of the most annoying and often troublesome parts is actually the internet connection between the site and us. That the data, when it gets down to the site, actually also gets back to AstroForge, and our commands get from us to them. Once it's set up, it's great. It's just those little things. So the test is an end-to-end test, right?
Okay.
A successful test, we send something out there and we say for RF compatibility, and we say we send a command from here to the ground station. It goes through the whole loop, goes to our simulator, which is pretty sweet. Comes back around, comes back down, we get the data back. That's an end-to-end RF test.
Yep.
It tests a lot of things, but not everything. So that's kind of the bench. I would say that's the benchmark of testing we're going for, and we're going to try and repeat. We did 3 of those, 2 at sites and 1 at a lab.
Okay.
Before we look to do more of that in the future. Then, so that's like in advance.
Yep.
And then before, during flight, anytime, you can get time on the dish and do loop back testing where you send a signal, they turn it around either before it gets to the antenna, which means somebody else can be using the antenna. You don't have to book the antenna, you just need the radio. Or you have to turn around at the antenna and bring the signal back.
Yep.
And then you don't need to send a simulator out. And because of that, you can do this test many times. The problem is just antenna availability, right? So that's the other kind of test we plan to do at scale. The third test we plan to do is just look at something in the night sky. This sounds so dumb in retrospect, so simple that we should have done this.
Just calling it like it is.
Just look at something.
Yeah.
Anything in your frequency band and say, do I see something? Because if you don't, something's wrong,
Yep.
and we uncovered one error at one of our ground stations like that. So that's a new test for us.
Okay.
It's a new test to the test suite. So I think that's the additional test, and then we're also going to try and test more ground stations. And then there's more, like talking about that automation. When we did these tests, you'd save a configuration. So okay, you set up the radio. One of the things that is hard to maybe convey is these radios are designed to talk to basically any spacecraft.
Okay.
So they need to be set up to talk to our spacecraft. It's not like a special on the ground. It's not like a special thing that only talks to our spacecraft, right? It needs to be set up to talk to our spacecraft. And if you set it up wrong, it won't talk to our spacecraft.
Yep.
So a lot of the point of the testing is how do you set up the radio? And how do you save where you set up the radio? How do you set it up the same way the next time? If you change it, how do you know you changed it? There's a lot of it's very detail-oriented tracking that we're automating
Yep.
a lot of for Vestri, of just kind of trying to help computers are good at detail-oriented.
It sounds like
tasks.
trying to set up a Linux operating system. Like you got to know where the secret checkbox is that says just make it work.
Yeah, basically.
So it's not a Mac.
It's not. It's definitely not a Mac.
Yeah.
Yep.
100% agreed.
We want Macs.
Yeah, so if somebody build?
Dude, we don't even have Linux. We have
Yeah.
I don't know, Arduino.
I mean, the craziest thing here still is that there's this mythical figure in the world. His name is Peter at AMSAT. Is actually the first one that listened and heard
Yeah.
Odin. And we found this out by watching his YouTube channel. Chap came to me and said like, oh, this guy on YouTube says he found the spacecraft. I was like, Chap, it's been 8 hours since launch. I don't care. This is not
Actually,
real.
you just told me to fuck off.
Yeah, probably. and then we look at it, we're like,
I mean,
oh,
that's
this
what he
is-
meant. I
this
mean,
is
the
actually
language he used
No,
might have
I'm
been.
just saying that's what he said.
Yeah.
This is revisionist history.
Yeah,
but,
yeah.
Because this also happened at 2:30 in the morning.
Yeah, he'd been awake
Yeah.
for a while.
It was kind of irrelevant what
Yeah.
time of day it was.
Yeah, but it's crazy that was where we got the first signal from, because this is such a complicated thing to get the chain correct.
And then it was like, well, that is our frequency.
Yep.
When we actually looked at the packet, like, oh, this is clearly from Odin, right? We could do some investigative reporting and realize, oh, this is the correct header, this is the correct checksum. Like we understood that was an Odin packet, which was really cool to see. Didn't solve the problem, but at least we heard from it. So
Reporting? You mean investigation?
whatever. That's all how we screwed it up on Odin.
He was so fast to get to a blog.
Yeah,
What are we doing to fix it?
it's a good question, Robin. What are we?
Oh man, did I feel the dump truck
You
run over
walked
me?
into that one.
Yeah, so the first thing we did to fix it is
Oh,
we
look, he's gonna
actually
answer his own question,
delegated
Demyan.
all of this to Robin.
Yeah.
Yeah.
And so now if it's not fixed, it's Robin's fault.
And
All right,
Robin's
you
just going to clone Demyan, and that's the problem, right?
What's the problem? Yeah.
No.
No problem.
Yeah, solved. I think that it's hard to each of the little things we talked about by themselves, like, oh, let me have a database that actually stores this stuff. Let me automate this one little step. Let me do this thing. They sound like small things, but so many of these steps have to happen correctly. Like the complexity of the ground system is not in any one part, right? Every part of the ground system is not that crazy by itself, but it's like a orchestrated, it is an orchestrated dance of these, bunch of components all over the world. They need to talk to each other correctly. They need to be in sync in time and schedule and planning. You have to synchronize with the people who are running all those things. And it's not like one thing. I wish there was one thing. I wish there was like a commercial DSN that we could be like, please fix it for us and just deliver the data here. Thank you. That would be fantastic.
I feel like I heard of somebody trying to do that.
There is this company out there that is trying to do it.
Hmm.
There is actually. After we did this, one of the things that happened is there was a company formed called Cascade Space that is exactly trying to do that thing now. All of these are disparate networks, and so it's really hard to configure. And what Demyan's getting at is the way we kind of solve this is by automating all those configurations as much as possible. We can test faster at each milestone, and that's what we really need to do is test more. The way you test more is by getting more automated with it. I hope that whether it's Cascade, whether it is whatever network SpaceX makes.
Well,
or-
and there's others out there. I mean,
Yeah.
KSAT's
KSAT,
working on
Intuitive
Deep Space
Machines,
Network.
SpaceX.
So is SSC.
Maybe
So-
one day we can afford DSN. But there is a clear way to.
Well,
go
they'll just
solve
shut it
this.
down and we'll get it in auction.
Ooh, some big dishes at auction shortly.
Yeah, but they'll be highly discounted because the engineers will take all the baseband units.
I think the real problem with DSN is you have to get somebody out to Goldstone, which is in the middle of the desert where nobody wants to live.
Dude, if I can talk to my spacecraft, I'm in.
Yeah.
Fair.
I'm really excited for the animated short that Rachel's about to make with Fucking Robin at an auction bidding on DSM.
I mean, to be fair, Robin's trailer is in the back of our shop. You
That's
can just
true.
hook that up to the
Oh,
truck,
yeah,
go out to
he's
Death
ready.
Valley, and you're
He's-
good to go.
He's
This
ready.
is-
He's ready.
I feel like I just got doxxed. First my phone number, now my physical address, man. What? I mean, you're going to use my driver's license
wait,
next?
we-
My passport?
We didn't say that your trailer is your physical domicile. We didn't say that.
Yeah.
I mean, how much am I here?
Do we need to update Rippling?
What do we do from the team side? Like, we built out the team that helped.
We should
with
also
all this.
mention on Odin, our ground station team was one person.
Yeah.
Like this was a undertaking of a century by one guy to try to figure it all out, and
Yeah.
then part-time Demyan to be like, well, I hope I got to figure out the trajectory. I got to figure out how to navigate this thing. Also, here's the passes, and let me WhatsApp some random people. So like the team here was maybe 1.2 people. That's not the correct size.
Yeah. No, I mean, so we definitely have augmented the team with additional talent and frankly, time and probably most importantly now, experience. I mean, all the different elements of the technical, non-technical, contractual, licensing, we have now experienced in a way that we had not before Odin. And so going into Vestri, we know the right questions to ask, the right tests to run. We know that we can't rely on service providers to solve our problems. They often are helpful, but they don't really know our spacecraft at all.
Yep.
And often they don't even know their partner ground stations all that well. We're all figuring it out together. So part of that automation is then also making sure that the configuration that's being loaded for any given pass is the one that we freaking tested.
Yeah.
So that it's not like, playing a game of memory or like, oh, which file are we supposed to load? Are you joking? Like this is costing us, hundreds, if not thousands of dollars an hour. And we're paying for that time. So that sucks. But, so we're doing all that better. Also, we have a little bit more time to to work with our ground stations and service providers to look across the world to be able to get better coverage and be able to do analysis on making sure that we have backups. We also, on the spacecraft sides, dramatically increased our transmission power and receiving sensitivity, opening us up to other ground stations that we can use. And we increased our overall battery life such that if we have a problem on the spacecraft, we expect, or on the ground station, we expect to be able for the spacecraft to be able to live on its own before receiving any commands and continue communicating with us and receiving commands from us for much longer period of time. So, I mean, those are a long list of changes, all of which are important, kind of to Demyan's point, like each one of these little changes makes a difference. It all adds up to a much higher probability of success.
But I think the biggest one there is if you look at the number of large 20-meter plus dishes around the world that a commercial company can reasonably buy or rent time on, it's not very big. It's probably 10. On Vestri now, we lowered that number to, at the beginning of launch, we can be down as low as 3 meters. Obviously, that disappears very quickly, and we're really in the 5-meter range. But if you look at the number of 5-meter dishes across the world, it's massive. And so by just increasing the dishes we can get on the ground, it allows us to have so many more shots on goal. And
but let's
not
talk
have to
about that
schedule an
because
issue.
it's actually not even that trivial because we use a lot of shorthand, particularly in the office, about talking about aperture size, right? So when we talk about 5 meter, 15 meter, 32 meter, we're really talking about the size of the dish, but there's some other things that go along with that. So those 5-meter dishes are actually part of a very specific network, and they're used to communicating with sats that are around the Earth. That their their operators don't even necessarily know where the spacecraft is. They're actually not coordinating a particular dish at a particular time. They're saying, can you please transmit this packet or receive this information from my spacecraft sometime in the next 24 hours or sometime in the next 2 weeks? I need 3 hours of time. It's very much more like a travel agent kind of arrangement for your data. And that's not true for us. So even going down to those smaller dishes doesn't necessarily totally eliminate a lot of the coordination work, because we actually need a specific pass at a specific time in configuration. And a lot of those networks are not designed for that. They're designed for these big LEO constellations where, oh, I missed it this time. That's okay. Just get it over the next country or the next pass. And that's just not how deep space works.
Yeah.
They're also, though, we're also like, there's so many details here. So apologies, but on most of these smaller dishes that are on the ground, the beam widths are much bigger. So
Yeah.
the area
Yeah.
over which you can have an angle offset from the board side of the antenna and receive a signal from your spacecraft is much bigger. It's on the order of, let's say, make up a number around 20 degrees on the ground, right? So you can be off by 20 degrees and still receive your signal. Keep in mind, on our India dish, it was 0.15 degrees.
Yeah.
Like, you not only need to know where your spacecraft is, you have to make sure you're directly pointed at it. And if you're off at all, you just won't hear anything. That's not going to be the case for Vestri, at least when we're in the Earth-Moon system, right? As soon as we get out of there, we're back in that small beam width. But that's an easy problem to solve once we're coasting through interstellar space.
Yep. Anything we missed on what we're upgrading with Vestri to make it better?
Better antennas, better radios.
Yeah.
Better lower transmission speeds to increase the link budget.
Better CEO.
Well, hopefully
we
we're
were
all
waiting for
hopefully we're
that.
all
We
better.
didn't change the CEO.
Self-improvement, Robin. Self-improvement.
Well, yeah, I think.
I thought no.
Yeah. One note on this.
You need a 360, dude.
Oh yeah, yeah. I have some comments.
Don't worry, we have a section for that later, Demyan.
Okay. Oh, you mean the
Man,
YouTube
that
section
should
of
be
this
our
video?
first tip. We didn't end up doing Eric's performance improvement plan on the air live, so we need to do Matt's pip on.
Eric, we should do Pips live. Like,
Yeah,
nobody looks at
we
the
should do
actual
your
running
Pip
a
live.
business side. Wow. If I could
I
fire
think they
myself,
just call
I'm
that
open.
a roast. That's just what we call it.
Yeah.
Yeah. Okay.
Yeah.
Fair.
That sounds good. But one of the things that, in terms of talking about improving that, we're actually, as much as we have publicly talked about all the issues that we've had with different ground stations, there's none of the ground stations that we're like automatically dropping, like, oh, well, we won't work with them. Because turns out we are all learning together. Like, we recognize that this is difficult. And
Oh, this is the plug for
different.
the community. The community is like super awesome. You're right.
They are awesome, yeah.
Yep.
And I think it's one of those things where, we already mentioned AMSAT's a big part of the big help, part of the community. But just in general, that like we I'm an engineer, I love talking about what went wrong and why. That's just like baked into your education for years and years. But the point is, we are learning together, we are improving, and so that's us and as well, and our ground station providers.
Yeah, and the new companies coming online that will help us here too. But on that note, there's also the whole community that helped us with getting the accuracy correct. One thing we did do successfully was update the navigation of Odin to know where it was. And you cannot communicate with something 800,000 kilometers away unless you know exactly where it is in the solar system. We were able to do that, not because we're good, but because a whole bunch of other people took pictures of the spacecraft and helped us find it, both from RF, radar, and visual. And that allowed us to be successful on that part of the mission. So like, there's a community here behind us that is awesome to see come out, and I think is ripe to just help us again as we go into Vestri. Please, if you're listening, please keep helping us. We
Oh
need
man,
it.
I wish we had a theme song right now, like something really inspirational.
You would take requests. You have an idea?
Rachel will put something in after
Okay.
in
Probably
post edit or something.
Metallica.
All right.
Metallica?
Yeah.
No, like what AstroForge is doing is freaking awesome, and I think that's part of the inspiration for a lot of these folks. It's not just like a day-to-day. I know some of the operators had people there, staying late and working long shifts and trying to help us and sending emails and sending us references to other people that might be able to help us. And it's not just, it just isn't another, it's not another Leo sat or constellation, that, they'll figure it out. No, they were like, we want Odin to succeed. And I know that's true for the other missions that were on that same rocket. And it's actually really inspiring to see, frankly, that effort across the world. That's not limited to literally any nation or ground station. Like, people were trying really hard.
So, if anybody out there is a musician and wants to create Odin's theme or Vestri's theme song,
Well, hold on. And you're good. If your song sucks, we're not putting it in
any
here.
submission is a good submission. in
So,
my
like,
book,
basically, you have to be like, and you're Metallica.
Just like, if you send me a folk song, like I'm out.
I don't limit.
Oh,
the
I'm totally
creativity.
going to sing you a folk song.
If you're a SoundCloud rapper, please no.
Please send all SoundCloud rappers to Matt at AstroForge.
Yeah, automatically.
And let's have that done.
What's his phone number again?
All right. Speaking of people, let's twist into the mailbag right now. Demyan, you're gonna have a question to ask. You get a chance to ask a question of both Robin and Matt, so have one on cue. I'm gonna go to the mailbag first.
Who set this up?
Hey, I'm taking
It's the
creative
bullshit
license
Chap
here.
does when he's narrator.
All right.
We need to give him more work.
We're going to start with Jordy. Jordy said, last week Matt mentioned that testing the radio at 100 watts is dangerous, but I'm curious as to why. We absorb several hundred watts of radiation just by standing in the sunlight, and radio waves are non-ionizing, so they shouldn't cause DNA damage. What makes it dangerous? I know there's laws against leaking 100 watts of radio, but I also know that laws are often dumb, so that doesn't always mean much. Jordy, what do you do for a day job? You want
Is that like Jordy Nelson?
I don't know.
He was a great
The football
receiver.
player?
Yeah, for the Packers.
I'm gonna guess that this is not Jordy
No,
Nelson.
well then I'm disappointed.
Why?
I'm disappointed.
Because his
Also,
Why are you
email-
making those kind of assumptions,
Because
man?
his last name on his email address is not Nelson, or their
Oh,
last name.
Oh, so it's okay to dox us, the host, but not
I
the
didn't
uninformed
dox.
public?
I'm
All
just
right,
saying
fine.
it's not.
Robin
Nelson.
is scarred from this whole dilemma.
All right.
Here's what I'll say is I have no fucking idea why. What I will tell you is there's laws in place, and they say that if you radiate above certain patterns, you're in danger, and if you go above 100 milliwatts, it's illegal.
Okay.
Actually, if you go at any power on the spectrum we're at, it's illegal. But if you go about 100 milliwatts, it's detectable and illegal. If you go above 1 watt, there starts to become a lot of health hazards involved. I don't know what they are. I'm not going to pretend like I know every single health and safety measure. What I'm going to say is when I see big danger stickers and they say things, and we're going to exceed it by 2 orders of magnitudes, I want to take a time out and say, like, let's not figure out why via experimentation. Let's go look it up and read it. And I think a big part of this is going and looking at people that are experts in this to say, like, okay, cool. If we want to go test this, how do we do it in a safe way? And what is a safe way? And they may come back and say, like, well, it actually doesn't matter.
Yep.
Cool. I don't want that to come from me. I don't want to guess.
True story. I had a microwave that only worked when the door was open. Like it was bad. You know, like normally they won't turn
Yeah.
on if the door, unless the door's closed. And mine.
Did you guys ever microwave Cheeto bags?
No.
You ever microwave grapes?
Yeah.
That's
Yeah. You want to see why you shouldn't stand in front of a 100-watt antenna?
Yeah.
Go microwave a couple grapes.
All right. I'm going to do it when I get home.
my first car. The radio only worked when the glove compartment was open at a very specific angle, so I had to tie it open.
What was your first car?
It's a 1988 Cadillac Fleetwood Brougham. It was all red.
Damn.
Sweet.
If it didn't get like 8
Don't you
miles
wish you
to the
still had
gallon,
it?
Oh yeah, if it didn't get 8 miles to the gallon, I would still have that thing.
Oh, you're rich now. You just turn that into an electric car.
Yeah.
All right, in the section that is going to be labeled, I think the call is coming from inside the house. Everest, why sell space on the craft when teams are looking for more mass budget?
Sorry, repeat the question.
Why sell space on the craft?
Oh, why sell space?
Yes.
Oh, why sell mass on the on the
when-
spacecraft?
When teams are allegedly looking for more mass budget.
Oh yeah, no, I actually said that. I was threatening to like go drill holes in the spacecraft if the structures team didn't get the mass down.
Yeah.
Why sell mass? I mean, it's called revenue.
It's nice to have.
I don't know if people have know this about us, and maybe it's hard to tell from the podcast, but this is a business, and like our job is to make money,
Barely.
first off. But I'll also say here, it's really important to have constraints. And as soon as you take off the limit of constraints, I mean, we've already seen it. Our base plate, when we first got proposed, it was what, 8-something kilograms, and now it's down to
11.
11?
It was like 11
and
kilograms.
now it's down to 3. And what happened there? Well, actually nothing, except we put more time and effort into optimizing for mass. And if you don't
and
build anything with constraints,
and
you
by
end up-
we, Matt means Eric.
I'm pretty sure me and Robin were in here helping
Well,
Eric
yeah, we were.
with a big, heavy sledgehammer.
Yeah,
It's typically how we do it.
yeah.
Yep.
But you have to have constraints to
Proverbial.
build a great project. And if you don't have constraints, you'll build something that fucking sucks. So
Yep.
these are two actual different things that just share the same unit of measurement.
And also selling space or mass,
Yep.
which mass is far more important than space in this case, on the spacecraft. Anyway,
It's a good tongue twister in there.
yeah, there's
Yeah.
something in there.
Yeah.
There's a good dad joke.
Yeah.
I was like,
There's a really good-
there's
yeah.
there's
Yeah,
something in there.
I'm happy to sell you space in space. Yeah.
Yeah,
absolutely.
exactly.
100%.
Like, let me sell you some space. Buy that bridge. All right. No, it's also important because going back to we're doing inspirational things, and the idea that a sponsor or an artist or NASA, I don't know, somebody would want to get on board our spacecraft and go out to deep space. It's not just about the Benjamins. I mean, it's also about partnering with people and entities that are doing inspiring stuff as well, right? Like people don't remember. We were just talking about this earlier today. People don't remember. Well, okay, if you're an aerospace engineer, you remember who built the moon lander. That's true, But most of the public doesn't know who built the lander. They just know Neil Armstrong was the first one to put his foot on the ground and miss a word in his first words on the moon.
Blame it on the radio.
Yeah, they tried that. I don't buy it.
The timing is.
Yeah, he just missed it.
just
It's cool though. Like, look, talk about under pressure. We can't even pull off a
Dude, can you imagine?
podcast.
I would have for sure tripped on that ladder.
Can you imagine? Like TikTok, man. Like
But I mean,
nowadays.
to that point, everybody remembers Neil Armstrong. Like, name one astronaut that was on Apollo 12, and if you can on Apollo 12, name one on Apollo 13. Like, unless you're in this industry.
Oh my
even then,
God!
it gets
Oh my
really
God!
hard.
He just opened the door to talk about Tom Hanks again.
Well, before we get into
Comments, yeah.
before we get into Tom
Feedback.
Hanks, we have one last question.
Oh,
This-
also, by the way, I mean, we're selling grams.
Yeah.
For the
But
next
I think it's
mission.
important to drive a point home here, which this is the first commercial opportunity in human history to fly something out of the Earth Moon gravity system.
Yep.
And I think it would not be rightful of us to not offer that to other people.
Yeah,
to
of
go
course. I
explore.
mean, they even did that on Messenger, right? Like, even Voyager, Carl Sagan got that record. I mean, like, it's a big deal. So,
Well, if anybody's listening and knows Tom Hanks and can convince Tom Hanks to buy some grams on our spacecraft, we'll make them
He'd
CEO
fly a
for
fucking
day.
typewriter. He collects typewriters.
It's
Tom?
a very small
How do you
typewriter.
know that?
Yeah, you don't know? Yeah,
All
he
right.
collects typewriters. All right.
All right,
Next
we're going to
question.
send this out
just
with
keeping the thread
a
going.
question from Havid Dodge. Matt, please tell the Pikachu story and how that relates to a fractured foot.
Oh, I know who this question's from. And the Pikachu story, I guess I'll tell the story just because he asked now. I was running a
Is this
marathon.
going to take a while?
No, it's going to take like 5 seconds because
All
it's a
right.
really basic story. I was running a marathon and it was mile 20. And this fucking dude passed me dressed as Pikachu. And I was like, I'm not losing the fucking Pikachu. Like, I would rather die than lose the goddamn Pikachu. So I started running even faster and I ended up fracturing my foot by running faster. But I would like to report that I did beat Pikachu. And then this guy that I don't actually like at all, total piece of shit, and I hate him, bought me a Pikachu costume to troll me. I've since thrown it in the trash.
So
and
hang
burned
on. You felt threatened by like a 12-year-old?
it. No, this was like a 50-year-old dude dressed as Pikachu. It was a
Mm.
6'5" Pikachu. You would have felt threatened too, for multiple reasons, Robin. And I was like, I'm not losing the Pikachu.
We got to get out
To
of
be
here,
fair,
man.
I
This-
did lose
I'm-
I did lose to a dude in a tiki skirt. So
Okay, all right, cool.
Can't win them all.
Demi, you got a question for either Matt or Robin?
Oh yeah, Robin. If you could get any ground station in the world, no bars. Which antenna you get? Which ground station?
I mean, like no limits?
no limits.
I mean, Gladstone.
All right. Now see.
wait, is it Goldstone or
Goldstone.
Gladstone? Yeah,
Goldstone.
Goldstone.
I was like, Gladstone, we can make that up for you.
No, I was sorry. I was totally.
First of all, fee. I actually own that one.
Yeah.
I got you covered. Don't worry.
I was thinking of Gladstones for fish over on PCH. I might be hungry again.
Thinking about fishing.
You might give you a sense of what time it is here.
Yeah.
All right. Well, on that note, that's a wrap. Demian, thank you very
Wait,
much.
can you get me Goldstone?
I mean,
It's a 70 meter, right? It's 70 meter?
Yeah.
It's all the meters.
That's fucking so nice.
I don't know what prize we
Only
have for
China
anybody
has
who
a
get
bigger
us
dish, right?
Goldstone.
Yeah.
but
No
we
more
got a big
prizes. No
prize.
more prizes. You don't get prizes.
Yeah.
Oh, if you get us access to Goldstone,
Yeah,
I'll send
you
you
get a prize.
I'll send you a
Yeah.
shirt.
Wait. What about I don't know the name of the Chinese one, the even bigger one.
Is it operational
I
yet?
don't
The
know.
500 meter?
It definitely doesn't have an operational transmitter. I don't even know if the receiver is operational yet.
Can we just use
building
like
it.
part of it? Oh, that's not how that works, is it? Oh.
Probably not. I'll
We'll
borrow
just use like 200 meters.
I mean, it'd be great to use Arecibo pre-falling into the jungle.
That's true. True.
Yeah,
Arecibo-
I bet you get it at a
Rewind to
discount nowadays.
All right. We're off the rails here. All right, Demian, thank you very much for walking us through ground comms. Tune in next week, and we will be
Gladstone.
talking
What was I
about
thinking?
not Gladstone, but orbits, maybe. Yeah, we'll talk about orbits next week.
Who knows?
Awesome. That's it. Thank you.